Hi, I'm Peter Kerbel from Data Science and Consultants, making another video here for datasciencing.com. In this video, I'll be talking about overfitting in machine learning models and how to look up for those. So if you're ready, let's have some data fun. So in this example, I'm going to use 4 different machine learning models or techniques: the kernel, support vector machine, naive Bayes, decision tree classification, and random forest classification. I'm not going to go into the details of the difference between all of them and exactly what they do. I just want to show examples of overfitting. And get the data set here. This is similar to my other video. We have a car dealership, has here a data set of customers, and in these models will be using the age and estimated salary to predict if they will purchase a vehicle. So this data set shows that if they've purchased the vehicle or not. The 0 is they didn't, and the 1 is they did purchase. So we'll use these to train the model and then predict if they will buy it. So if you get another data set from, let's say, another branch, or in the same city, or let's say you go to a different city, and you want to use this model to predict if those customers will buy this SUV. So you make sure you have enough in stock, or maybe there's not enough interest, and you'll try a different promotion. So this is the kernel support vector machine, and here you can see it has a nice smooth curve dividing the two groups. So the red here are the ones who it predicts in this red area who wouldn't buy it. This is from the training set. So if you ignore all the dots, if you just look at the green, this is where it'll predict people would buy a vehicle, and then these are the actual values. And here is the confusion matrix. This will show you who these are actual people who bought it, and this is what the model predicted. So it predicted 64 and 29 correctly, so it predicted 93 correctly and 7 wrong, so it's 93% accurate. And so we'll check out these other models. Here's the naive Bayes, and this one also has this nice smooth divider between the two groups, and it was 3 and the 7 is 10, so that's 90% accurate. And so it's less accurate, but also had this nice smooth divider, so you can distinctly tell, or it makes sense who would buy and who wouldn't, because you're expecting high salary and or higher age, and this kind of shows where those exact dividers would be. Now we'll go to, here's the decision tree, and this one here is 6 and 3 is 9, so this one's 91% accurate. So it's more accurate than the naive Bayes, but it has all these weird boxes of groups, so it predicts anyone in here wouldn't buy the vehicle. And then for some reason, because of these groups here, because there's a whole bunch of circles here, it thinks anyone in this category would buy the vehicle, but then all of a sudden over here it says, oh, someone here wouldn't, because it's one dot here and it predicts. So it's not quite as obvious if you all of a sudden had a new group why people over here why it predicts people wouldn't buy it and over here they would. And I'll check out the random forest, and this is a similar issue. The accuracy is 5 plus 3 is 8, so it's 92% accurate, but it also has, again, it's not as bad, the blocks or the boxes, but still has like these almost like random group up here, which isn't as reliable as the naive Bayes and the kernel support vector machine. Here, I'll show them all side by side so it's easier to understand. So let's say you had a data set. Let's say this is for data set for Winnipeg, and then you want to check out what's going on and use this for prediction for like Regina or Calgary. Let's say you had a whole bunch of customers over here. This one, you can distinctly tell, okay, it'll predict these people would buy the SV, these people wouldn't. And here would be the same thing. If you kind of get the same area, you can tell, and you can kind of make sense of it. Where over here, if all of a sudden you have all these customers, and then it predicts, okay, some of these here wouldn't buy it, and all of a sudden these people here would, especially over here. Those are obviously the extreme examples, so this would be less reliable. We know it's more accurate than naive Bayes, and same with the random forest. Just to emphasize the point, it's not as bad as blotchy as the decision tree, the random forest here, but it still has some odd spots here. So for some reason it thinks someone in this group here wouldn't buy the SV, even though all the other ones predict they would, which makes sense with the higher age and although it's low salary, all the other models predict that someone would. So that's what this is overfitting. So I forgot to mention, yeah, this is why it's too dependent on this actual data set of the group. So it's hard then to use these predictions in other areas, whereas these ones is easier to use, because especially it makes sense and they're distinct two groups. And so yeah, like if you had someone from a dealership, another dealership in the city or a different city or anything else, or if, depending on your business or needs, whatever you're looking at, these ones you have to be more cautious using. In this example with this data set, other data sets they might work out better. So that's why with machine learning you gotta try out different models, see which ones work best, which ones have good classifications that make sense and that are actually usable for other data sets, other groups or cities that you're looking at, as well as accuracy as well. These ones are quite accurate. They're all 90% or more accurate, but you might find some models that are that have good distinctions like this, but if they are quite inaccurate, like the 60% or 50%, then it's also not useful because it's closer to just do a coin toss. So that's why it takes a while to test your models and see which ones you want to use, or if you're getting someone to help you out with machine learning, help with your business, a consultant or someone. This is one of the reasons why it takes a while to make sure it's accurate, and they want to make sure they give you the best models and best predictions. And there isn't just like one that's overall the best all the time. You gotta test it out with a data set and do different like experiments and verifications. So this is what I mean when I talk about overfitting in my videos, is that sometimes it's too much to whatever the data set is, and so you gotta be careful of that. Thanks for watching, and you can check out my other videos on YouTube, Data Sciencing, and Twitter is Data Sciencing C. Instagram I'm Data Sciencing. Please check out my website, datasciencing.com. Thank you. Bye.